and also something reflects a too much light.
Hello everyone, my name is Anthony. I am a 6th semester comm student in ELM, besides a lot of you. My project for TPJ is what I like to call digitally controlled analog surround sound. There are a lot of homes in the world that have surround sound systems. There are a lot of content creators who make content in surround sound, and it is a very expensive thing to produce. You need a lot of DSP, you need a lot of control, you need a lot of automation, you need a lot of things. In a typical surround sound, in a home stereo, you have a left speaker, left surround, a center speaker, and a right speaker, and a right surround. So you have a mirror image of everything. Because music was recorded a lot in stereo, the trend is that left and right speakers are better than the rest. Some people don't agree with that, and a lot of the major manufacturers of surround sound systems, most notably IMAX is the leader in this, and what they do is they have full bandwidth speakers everywhere. So when the bass hits you, it's not synthesized, it's not a channel, it's not discrete anything, it's natural because it is a 5-point none system, they like to call it. So I asked, how do I make surround sound? Let's call it on the cheap, or in a way that nobody else has ever done. My background in electronics is mainly recording studios, mixing consoles, and environments of production. So one of the projects we worked on was this console from scratch. This is a stereo console, so you have your big 2 speakers, and you have buses that feed to these 2 speakers. This is an adding machine, so 32 sine waves come in, they get added to left and they get added to right, and then poof, you have a record. That is a traditional way of making an analog 2-channel mix. I want to make an analog 5.1 none analog mix. So this is what we started exploring. Simple thing. You have 2 inputs, 4 inputs, 100 inputs, I don't care. You have X inputs. You have a volume controller and you have a position. Those were the 3 things I wanted to play with. Dolby is the leader in all of this stuff. Dolby is the proprietary information holder of encoding and decoding. So what happens is software panners like this. You have your speakers and you have your positioning and you have divergence are all done in a software that sends discrete tracks to an encoder that gives you Dolby. So you get a Dolby encoded signal. Dolby owns this. When you buy this piece of equipment from Dolby, you don't own it. You own the license to be able to use it in your productions. So I would like to say there's no need to decode a lot of this stuff nowadays because the bandwidth is huge. Let's exploit this. Who cares? 10 gigs? Who cares? I'll get a record that's 10 gigs. How they move these, what's called objects in the 5.1 sphere, they use joystick controllers. And these joystick controllers, like that's an industrial Penny and Giles $480 joystick controller. That unit is $3,500. This unit here is the Pro Tools equivalent. What they did was they took it out of a console and made a separate unit, and that's $2,500 just to be able to access the software. Mine was simple. I wanted a single potentiometer that panned from left surround to left to center to right surround. One control, one human user interface. That's as simple as I wanted to make it. I'm going to show it to you right now.
Let Murata do the cow.
Oh my God! Does anyone know how to use this? Where is this? Okay, so I have a tone generator here generating a little bit of noise.
Hey, no pictures.
You know, you're in a lab, you might as well take advantage of all the things that are here. So I've got some noise, and I'm going to pan it. I'm going to pan it around to the back. Now let's get a sine wave. And okay, so I have it coming down the center, and with one move, I can move it to that speaker, I can move it to that speaker behind you. I can go to the other side, now I'm in that speaker. Now I'm in between these two speakers, and I'm over here, and now I'm up front. I'm gonna make a phone call. Lee, can you help me? Could you help me make a phone call?
Yes.
Does anyone have an iPad or music? Who listens to music here?
You already got music on this.
Who's got music? Let's get somebody else. Let's make this phone
You
call.
wanna make a call?
That last phone call.
Led Zeppelin.
Just a call. I have a switcher so I can change my input, and that is done through RS422 protocol. Let's make a phone call here. So imagine having a conference call with a whole bunch of people. And I want to talk to,
Hello.
Elizabeth,
Hi.
it's me.
Hello, Anthony.
There's a classroom here, and they
Hello,
are.
everybody.
Hello, Elizabeth.
You're now behind me.
Oh, great.
I got a question. What did I build for my project?
You build a speaker system?
That's exactly it. Okay, thanks, honey.
Okay, here we have it. Bye-bye.
Bye-bye.
We got the point.
You get the point.
got the point.
All right. So, Lee, I gotta get music on this thing. I don't know how to operate this phone. It's not mine.
Oh, it's okay.
I'm gonna show. So this is one channel. You can take this and you can do it a bunch of times. So here I have one input. If I, made it bigger, I could have. Let's call it X. I would like to sell these, so let's call it X.
I'll put volume in half.
Anything you want. So I can move it between any of the speakers. If I really crank this up, how do I crank this up?
Just push the volume button.
Volume button. There's no volume button. All the way up. So as you approach the red, it tells you, stay back. So the meters are helpful when diagnosing where sound is and why it's there. Very good. All right, so we'll go back here. How did I do this? Come on, projector, laptop selected. Okay, so this is the human user interface. There are 4 buttons of volume and surround encoder. I wanted to use analog feeling everything, so everything is analog. There is an analog to digital converter on each thing that moves. There's a dedicated analog to digital converter. The pod input selector is built by Wardbeck Systems. They have I have 4 inputs, and I'm doing an RS422 protocol to that. This is the magic. This is the digitally controlled analog surround sound panner. They are chips that are digitally controlled potentiometers that work on an I2C bus. From the output of those potentiometers, it goes into a summing system. So like I said before, you could add more things into this. So you could have, this is 1 channel, imagine X channels. Then you have 5 amplifiers and then 5 speakers. The process started with mechanical design. I'm very interested in a thing called Eurorack. Eurorack is a synthesizer that uses a standard size and footprint. So when I came up with what my requests were, I wanted it to fit in this package. So I started with the mechanical layout to make it fit into this small thing. And okay, I've got one here, it's pretty small. The company that I work at is called Wardbeck Systems. They make established products, and they have allowed me to jump into their warehouse and say, take what you want. So I grabbed their buttons. They had these pots already custom ordered, so it's like, okay, one less thing to worry about. But then I added these NeoPixels and this fader. This NeoPixel, digital in, you send it RGB, and it will display tricolor LEDs, and I can show you a little bit more about those. I drew and 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 I drew. I think there's 14 pages of drawings just to make this thing happen. My big thing right now is I exploit quad twisted pair cable, so everything internally is balanced. I use RJ45 connectors as often as I possibly can because they're quick to set up and tear down. Also, the different twist ratios within a piece of cat cable help with crosstalk reduction, so it is just the most ideal cable for audio. Power supply, I needed plus minus 24 volts to run the summing amp, plus minus 7 volts to run my audio side of the controlled potentiometers. The Huey was the beauty of working in a factory. You need a rack-mounted tray. Just go to the garbage and they got rack-mounted trays everywhere and you just stick it on and away you go. All of their buttons were repurposed and then wired to the Mega and so on and so forth. The digitally controlled potentiometers, I'll talk about those in a second. Meter bridge, this is a prototype of a meter bridge. I just took it on a bandsaw, chopped it up, love destroying things. So this is how the original design corresponds to what's on the panel, what you see right there. The pod system, this required a serial transceiver because when you push a button here, it sends data. When you send data to it, it kind of pushes it back out so you can link these things. Very quirky box, but now that I've worked with it, we are going to do a couple improvements. Had to write a couple functions to make the pod input change and get the data back from the pod in the next generation of stuff. Line inputs were done with this THAT chip. This THAT chip is a balanced receiver because it simplifies things. I wanted to do a couple op amps, but for the time and the dollar, one chip, low footprint, does everything for me. These are the digital decoders. Each one has an address, so you have to address those according to an order you want it to be in. Then from the output of the digital potentiometers are line drivers. These line drivers, again, everything's in one chip. I get unbalanced in, balanced out, perfect. QTP, out, RJ45. Okay, so here's the magic of the surround sound. I wanted to go from this speaker to this speaker to this speaker to this speaker. So I have one potentiometer, let's call it 0%, let's call it 100%, 0% and 100%. And I have an array. And I call this array based on where I am in this potentiometer. So this array, this was generated in Excel. So I take the curve, I move it, I figure out how wide I want it to be, and then I position it in Excel. I generate an array. I actually generated most of my software in Excel. I'm going to show you. So here I have this is the math for doing the rotational position. I created it in a percentage because a percentage is a really nice scalar. And then I made this formula, you can see, so I created an integer, K2, I take that percentage, multiply it by my range of 64, and poof, I get 64, and it generates all of my C code for me. So I just take this, as this, and I dump it into Arduino, and poof, there it is, there's my lookup. I've kind of gotten into this habit of automating as many pieces of software as I possibly can because I learned from guys who love copy and pasting, and it's the way to go. And it's the quickest way to do this. Instead of it doing math, this is the quickest. This is the fastest way to make that happen. Here I have the 5 commands to change the potentiometer. So I created a function called change pot, 0, 1, 2. There's 2 halves of each pot, so you have to address those differently. You have to scale. I have a fader, a master fader, so I use that to scale this, while it calls this array based on this fader position, and it calls channel 1. So it's a lot of little things going on at the same time, but it's very quick math because it is a division, a conversion, and a multiplication. Instead of doing math for every one, I look it up, do a little bit of math. Very, very simple. I2C, that was the main bus that all of these go through. Very awesome protocol, but again, awesome when you have the libraries for these things. So I had to create a transmission library for this because you have 2 sections of the pod. So you had to send two different values every time you address the pod. You would adjust the wire number, send it a value. So wire value, wire value, wire value, wire value, sent it 5 times. Problem with this, you have clock is noise is everywhere. So if you let it constantly poop out data, noise in the audio stream. So when I make a change of the fader, it says, has there been a change made? Is there a change made? And then it sends the data. Because as I was moving it, or as it was constantly sending data, you could hear it through the speakers. And that was no good. That's how it was done. Any questions?
Size. Question about the size. Is there a way to shrink it down?
Oh, absolutely. Yeah, proof of concept, you just work freely.
No, that's what I meant, because that's not the proof of concept, but it's, do you think you can make it more digital, or is it,
I'll show you, this is the actual, I have one of the panels. This is the ideal. Oh, I thought I had. Anyway, the panels are like this big.
Okay.
So imagine 1, 2, 1, 2, 1, 2, 1, 2.
okay.
So in a standard rack case, I would like to be able to get something like that wide. So you should be able to get 10 of them in something like this. The summing amp can change quite a bit, but it was just made big because this is on the shelf for me. I don't have to re-engineer this, but I would like to re-engineer it. Now that I've got a test jig for it, I will re-engineer it this way.
And then cut it back down.
And then cut it back down.
What if you took some parts of those and made it digital, like you cut out some of the operation, made it digital? Would you lose some functionality? Would you lose any of the sound quality?
No, not necessarily, because in my original proposal, I had 2 microcontrollers controlled by Ethernet.
Okay.
So it's X in between there. Once it's digital, it's X. So
you can scale it to wherever you want.
you can scale it to wherever you want. But the growing trend in this community is, I'm going to give you this little module. So in the end, you know, you get something like this. This is the product. It's digitally controlled, and how would you like to use it?
Yeah.
But so this was the exploration of getting that.
3 minutes.
Okay. Any other questions? No.
I'd like to ask a question about the application of
Okay.
this. I see how you're controlling the channels to go to various sounds, the various channels and that. How would you actually use this to make? Do you use it to make a recording, or are you using this to actually control something that the signal is already coming?
You could use it. Let's say you're at a rock concert. Let's call it a live application. Let's say this live application. You have 30 inputs into this thing, and you have 30 of these positioners, and you have 5 outputs. So you could send it all of these little pieces of sound anywhere you wanted, and then poof, all of your audience hears that sound. But in between the playback system, you could incorporate a recorder that is a discrete 5-track recorder, and then you could play that back. Most computer sound cards, guys who are doing this stuff, they have hundreds of inputs, hundreds of outputs. So to chew up 5 as a main mix, that would be how they do it.
So as your system is going through for each individual component of the sound, you're using this tool to assign it to a mix of these channels, then I go to the next sound and
Yes.
so on and so forth?
Yeah.
Where is all that information stored?
There is no information actually stored. This is all real time. The summing happens in those summing cards. So if I have multiple inputs, they could be live microphones, or they could be recorded playback off of something like a multi-track recording system. So if you had something like Pro Tools with multiple outputs, 24-track outputs, it would come from there. So the data is everywhere. Future viability, mixing console retrofit, that is a big chunk of my business. I retrofit mixing consoles with new buses, new panning, new hot rod. I like the hot rod mixing consoles. Modular synthesizers are big guys. Those are the guys who make the music that goes beep, 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 beep. But imagine that music now in 5.1 surround sound. Broadcasters, like I said, if you have a telephone or if you have an intercom system with multiple people, you never want to hear 10 people yelling at you out of one speaker. So when you are doing an intercom system for broadcast, you can actually position different people around you so it's not like one thing is yelling at you. Home use, I don't know. I'll tell you about that if you really want. What else is there? I think that's it. Home theater. Home theater. I'll tell you, the home theater stuff, we'll talk about that later.
Thank you.